In Lesson 8-3, we will be looking at tests for parallelograms. You will recognize conditions that ensure a quadrilateral is a parallelogram and prove that a set of points forms a parallelogram in the coordinate plane. How are parallelograms used in architecture? The roof of the covered bridge appears to be a parallelogram. Each pair of opposite sides looks like they are the same length. How can we know for sure if the shape is really a parallelogram? Those are the tests we're going to look at. Now, by definition, we know that a quadrilateral is a parallelogram if the opposite sides are parallel. We have 4 theorems here, which means they could and have been proved somewhere. Both pairs of the opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. 8-10, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. 8-11, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. And 8-12, if one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. If you'd like to see the proof of Theorem 8-10, that's what they have done in the book for Example 1. So we're going to jump into Example 2. Some of the shapes of the Bavarian crest appear to be parallelograms. Describe the information needed to determine whether the shapes are parallelograms. For their example, they just restated all of those theorems we just went over. So either if both of the opposite sides are the same length, or if one pair of opposite sides is congruent and parallel, then the quadrilateral is a parallelogram. If both pairs of opposite angles are congruent, or if the diagonals bisect each other. So there are the 4 theorems restated in sentences. I would not necessarily suggest writing all of that down if you already wrote the theorems down. Determine whether the quadrilateral is a parallelogram. Justify your answer. Well, it looks like from Theorem 8-9, we have both pairs of opposite sides are congruent, so that is a definite yes. Here they restate the definition and those 4 theorems that we already went through. I would suggest if you haven't written down the theorems, write this down. If you've already written down the theorems, don't write both because it's kind of redundant. We have, by definition, both pairs of opposite sides are parallel, or both of opposite sides, pairs of opposite sides are congruent, both pairs of opposite angles congruent, diagonals bisect each other, or a pair of opposite sides is both parallel and congruent. Now here's the stuff we like. We have a diagram. We're going to solve for x. Find x so that the quadrilateral is a parallelogram. So if it's a parallelogram, the pair of opposite sides have to be both parallel, which they're marked, and congruent. So that means 4x minus 1 should equal, I'm going to go ahead and distribute if I may, 3x plus 6. Hopefully that's not too big of a deal. And then we can subtract 3x from both sides. So x minus 1 equals 6, add 1, and we have x is 7. Find y so the quadrilateral is a parallelogram. Okay, from Theorem 8-10 we see that both pairs of opposite angles should be congruent. So this time our equation is going to be 5y plus 28. That's a funky 2, equals 6y plus 14. The purpose in the parentheses there is just so it's all degrees, it's all good. So all we have to do is subtract 5y from both sides. So we have 28 equals 14 plus y. I don't know why I moved my 14 for no apparent reason. So 14 equals y would make that a parallelogram. We have 5 different ways now to make sure that a quadrilateral is a parallelogram. So they're very specific. Determine whether the figure with vertices given is a parallelogram, and they say use the slope formula. So slope formula we know is change in y over change in x So for segment AB, just going in alphabetical order for no apparent reason, the slope would be change in y, so we go 3 minus 0 over change in x, -1 minus -3, which becomes plus 3. So I have 3 over 2. And I'm going to check the one that should be parallel to it, because if I get one pair that doesn't work, I'm done for. So for CD, change in y, we'd have 2 minus -1, so plus 1, over, we started with a 2, so now we need to start with a 3. 3 minus 1, so I have, 3 over 2. Okay, so far so good. Those two are parallel. And now I get to check the other two. So for BC, change in y, 2 minus 3 over change in x, 3 minus -1. I get -1 over 4, which it looks like it's going down 1 over 4 looking at the graph, so of course. And we have to do AD yet. Slope, ooh, that's an ugly M. Slope of AD, change in y, so we'd have -1 minus 0, that's a stumper, over change in x, 1 minus -3, and once again I get -1/4, so those two are also parallel. So this would be a yes, because opposite sides are parallel. Okay, they gave us another quadrilateral, and this time they said to determine if it's a parallelogram by using the distance and slope formulas. So that means we're going to see if there is a pair of sides that is both parallel and congruent. So let's do distance formula first. So let's do PS, why not? So I'm not putting a bar of it because I'm trying to find the length. So I want the difference in my x's, so -3 minus 1 squared plus the difference in my y's, -1 minus -3 squared, and then we get to do the square root of the whole business. So I've got 4 squared, I don't care that's negative because I'm squaring it anyway, plus 2 squared, square root of that, 16 plus 4 is 20. And I think I'm going to be lazy and not simplify it. If I need to in a minute, I will. Let's check QR, because if QR ends up being a different length, we're done. So we do the difference in our x's, -1 minus 3 squared, plus the difference in our y's, 3 minus 1 squared, and then we have to take square root of the whole business. So again, we have 4 squared plus 2 squared, so it's going to be square root of 20 also. Okay, so far we have opposite sides congruent. That's nice. Now we just have to see if their slopes are the same to see if they're parallel. So the slope of PS, we're going to do change in y, so -3 minus -1 over change in x. 1 minus -3 is -2 over 4, which I can't help myself, I'm going to reduce it, be -1/2. And we'll check QR as well. So the slope of segment QR, change in y, so 1 minus 3 over change in x, 3 minus -1 is -2/4 as well. So, oops, -1/2, sorry, my equals and my wah. So the slopes are the same, so they are parallel. So this is going to be a yes as well. We could go PS is congruent to QR, and PS is parallel to QR. Put a little hand sign in there, that's pretty. So third time around, here's another summary of the test for parallelograms. Obviously, by definition, if both sides are parallel, and then our theorems were both pairs of opposite sides are parallel and congruent, both pairs of opposite angles are congruent, diagonals bisect each other, or a pair of opposite sides is both parallel and congruent.